Yay, it worked. Okay, so good morning, everyone. Most of you probably know me, and I apologise for not remembering the names, but my name's Ciaran Morgan, M0XTD, and I'm the ARISS team lead in the UK. What I'm going to run through today is a little bit about some of the contacts that we've carried out, or one of the contacts that we've carried out this year, sort of give a little bit of heads up for some more that's happening. For the one that we did carry out, I've actually got Eleanor Griffin, who was the student from Keynes High in Warwick, who's come along and is going to give an impression from her side of what's it like being involved with an ARISS contact, what she's got from it, what she's learned from it, and what sort of inspiration it's sort of given her for her future career. Going to update you on a couple of things as well. The ARISS live stream, we've now got a ARISS facility for doing live streams, which makes finding them an awful lot easier. I'll talk a little bit about the Interoperable radio system, which is a new development going on for the space station, and I'll go into some of the background with it as well. I'll do a little bit on HamTV, and also something that's has recently started working on the station, something called Markinista, which is a really nice little experiment. So we've done one contact this year. That was at the King's High School for Girls in Warwick. A very successful contact with Ricky Arnold. I'm not going to say too much about it because it's sort of Eleanor's sort of pride and joy, so I'll let her talk about it. But we do have another one coming up in December in Kenilworth School. There is no correlation to the fact that Warwick and Kenilworth are within spitting distance of each other and very close to my home. Yeah, and if this works, no it didn't. We've got another one coming up at Rowan Prep Primary School in Claygate in Surrey, which will be sometime in the first half of 2019 as well. So we've got a number of contacts sort of keep on going, which is one of the legacies that we've picked up from the Tin Peak mission and the Tin Peak contact, because one of the things I want to do is keep the drive going with the success that we had. So with that, what I'm going to do is introduce Eleanor, and she's going to speak for a few minutes on the contact that she organised, what she did, how she did, and what she sort of felt from it. So up you come, Eleanor.
Good morning, ladies and gentlemen. My name is Eleanor Griffin. I'm 17 years old and I study maths, physics and biology at King's High School for Girls in Warwick. I'm a licensed radio amateur, and I'm also the first ever student to submit an application to ARISS to host a link to the ISS. Like most journeys, mine started with an inspiration. I've always been fascinated by space and the possibilities it holds for humanity in the future. My grandparents' generation put men on the moon. My parents' generation built the International Space Station. But my generation, it seems obvious to me, will put a man, or perhaps even a woman, on Mars. I am a firm believer that the colonization of the red planet isn't just some far-off future hope or science fiction, but our very real and approaching future. I think that being interested in space science and its exploration will soon become not a choice, but a necessity. The only issue is, you don't really get handed the opportunity to colonize a planet that often. Being able to start from scratch and learn from our ancestors' mistakes over centuries and attempt to build as close to a utopian society as possible is an opportunity out of this world, quite literally. We need to get it right the first time, because we will only get one chance to colonize a planet for the first time. So, how can we possibly expect the children of today to ensure humanity's survival? The answer is simple. Education. But not just the education of geeks and space enthusiasts and Star Wars fans. Every single person on this planet right now has the responsibility to ensure we don't wreck another planet with war, greed, selfish ambition, and a total lack of responsibility. And so, I developed the Warwick Mars project, a year-long exploration into the colonisation of Mars and space travel at the interface of a plethora of other subjects. Students studied communication and culture in drama and languages, nutrition in food technology, weather and farming in Mars in geography, preventing muscle atrophy in sports science, and the effects of solar radiation in biology, along with a whole host of different issues we will face. Throughout the year, the girls at King's pushed themselves out of their comfort zone in exploring new ideas, both in class and outside of the curriculum, via extracurricular activities. From our astronomy society to girls becoming qualified radio amateurs, to having our very own space scientist in residence who's gone on to become a permanent member of the teaching staff. This wasn't just limited to King's girls, but also our little brothers and sisters at Warwick Prep and Warwick School. While STEM is increasingly becoming a well-known acronym, science, technology, engineering, and maths, over the last couple of years we've seen the addition of an A. It now emphasises the importance of art and creativity in forging sustainable solutions, an aspect I believe is very important and encouraged students to pursue over the year. I decided that I wanted to research the core of the project further, and did so by taking part in the extended project qualification. My EPQ, titled "To What Extent Can We Build a System of Governance for a Martian Colony?", resulted in a draft treaty to provide basic law during the colonisation process. I did the majority of my research by reading treaties currently in force around the world, such as the International Declaration of Human Rights, and adapted this for the conditions on Mars. I modelled Mars as Antarctica being its closest comparison, and applied it hypothetically to the Outer Space Treaty. I also used treaties such as the Latin America being a nuclear-free zone, and the Treaty on the Reduction of Statelessness to address the use of weapons and granting of civilianship, respectively. Throughout the year, I was determined for the student to maintain its uniqueness in being a student-led initiative. This meant that my peers could see the work that I did and the opportunities it awarded me, and could exercise it in their own interests. I developed the Mars Society. Girls from King's wrote letters of application and sent in CVs to be selected for one of the 15 prestigious positions to help coordinate the year and especially the link day itself. The radio link up to the space station was the climax of our year, but was more than the 10 minutes we had with astronaut Ricky Arnold. We dedicated the day before as a space day. Students all through the foundation and across Warwickshire as our outreach programme had access to industry professionals and experts, giving lectures, doing workshops, rowing to the moon, and even seeing a rocket launch on our playground. Younger students learned about propulsion, learnt how to train like an astronaut, and made space smoothies, much to their delight. The ARISS team were there, preparing for the contact with their signature scaffolding and probing lots of questions from students and staff alike. On the link day, the whole school packed into the school hall. The ARISS team had all their equipment on stage, and I'm not joking when I say you couldn't move without tripping over a newspaper reporter, and even the BBC radio and television were there, reporting live. You could literally cut the sense of anticipation in the air as we waited for the space station to come over the horizon. I'll always remember my first ever radio call, a real one. NA1SS, November Alpha 1 Sierra Sierra. This is GB4 KHS, Golf Bravo 4 Kilo Hotel Sierra. Listening and standing by for a scheduled contact with the International Space Station. Over. No answer. NA1SS, November Alpha 1 Sierra Sierra. This is GB4 KHS, Golf Bravo 4 Kilo Hotel Sierra. Listening and standing by for a scheduled contact with the International Space Station. Over. Just static. Then, suddenly, Ricky came back with, "This is NA1SS, welcome to the International Space Station." You can imagine the relief in my voice as I said, "Welcome to King's High, Ricky." The next 10 minutes, honestly, went faster than any before in my life, as girls from all ages from across our schools came up on stage to ask Ricky questions. You should have seen the looks on their faces as they each got to speak to an astronaut in space. Thank you, Ciaran, and thank you, ARISS. Being a part of something so awesome was life-changing. Having the incredible opportunity to speak to Ricky led me through so many new exciting challenges, as well as guiding me through new experiences, which have paved the way for my career as an engineer. Gandhi famously said, "Be the change you want to see in the world." So here I go. Thank you.
She's a little bit more modest. She's a little bit more modest than she is. She actually got an A star for her EPQ, or Extended Personal Qualification, and that's the equivalent of an A star for an A level. So I think a huge sense of congratulations to Eleanor. And this is something that I hope that we'll see at future AMSAT colloquiums as well, and that what I want to do is actually get some of the students involved and get them in making potentially their first presentation at a colloquium, so that they can sort of quote the experience and everything else as well. But like I said, it was a great couple of days at Keynes, and I'm really pleased to hear what do you call him, has become a member of staff now. There's space scientists in residence. Never seen that happen at a school before, but it was a great add-on. Okay, so moving on, the ARISS live web stream. We all know in all of these multimedia days that you can go to YouTube, live stream, and this one and that one and the other one and something else as well. And trying to get the message across about what your organisation is, what it does and everything can be quite hard. One of the things that has been developed by Phil, M0XTD, sitting back there, is the live stream, which is a single endpoint for ARISS contacts that we're hoping to use. It's essentially the system that we used for the Principia contacts sitting behind it, but also importantly, it's got the capability of linking in the HamTV streamers. So when the HamTV is working, we can get signals from multiple locations and string it into a single video itself. So and get the live stream coming down from, the live video coming down from the space station. I'll talk a little bit more about HamTV in a minute. So the interoperable radio system. I know Joe Spears, the AMSAT-UK president, will say a few things about it, but I wanted to say about this as well, because this is really important for us. You may well have seen since the Tim Peake mission, we've had numerous issues and problems on board the station. First, we've had a problem with the radio in the Columbus module, the Ericsson. That's forced us to switch over to the UHF version of the radio. We've gone back to the VHF version with some more fixes. There were some more issues again. We went over to the service module, using the D710 there with its lovely 50 watts. But we've also developed some problems lately with some of the contacts that we carried out, and we switched back to the Ericsson in the Columbus module a week or so ago, only to have one or two contacts work successfully, and then we had another complete failure. So we've gone back to the service module. And what this does, and I don't know if you're aware, but the service module and the Columbus module are like that end and that end of the space station, and it takes a huge amount of time for the crew member to go back and forth. So one of the things that we've had as a goal in ARISS is to build a system where the parts that are used for the ARISS station can be interchangeable between the Russian segment and the US segment. Now you might say, well, why is that not happening at the minute? Well, one segment's 110 volts and the other one's 28 volts. So we need a power supply that links things up properly. Also, the HamTV system comes off a different power supply feed from the radio in the Columbus module. And that power supply is subject to interruption if some of the ISS experiments are running. So one of the things we've wanted to do is to put together our own power supply system and get it permanently enabled on the station, so that we can then power our own experiments. But really importantly, we can then keep HamTV running as well when it's working, and essentially sort of have a platform for the future as well. The key thing about this power supply is that it can handle both 110 and 28 volts. So the idea is to put it also into the Russian segment and keep some on-orbit spares as well, so that we have the ability to move things back and forth as necessary. We're also getting, hopefully, a brand new radio in the Columbus module. We currently have the Ericsson, which is probably 25, 30 years old, pushing out probably 3 to 5 watts, which is not an awful lot. The packet system that's there as well has been there just as long and has got similar problems with it. We're looking to replace it all with a new D710 with a lovely set of 25 watts coming out of it, which will make contacts from Columbus an awful lot easier to carry out. But in doing all of this, there's a lot of space engineering that has to go into it. And what we've got here is essentially a picture of what the whole system would look like. And this has had to go through all the planning systems, all the design systems for NASA to build this in order for it to become space qualified, for it to be safety certified and everything else as well. But essentially you've got the main power unit itself, and then the D710 will happily sit on top of it. That gives us a number of advantages. One is that we can control the airflow around it as well, so that we can keep the D710 cool when it's doing 25 watts. But also it means that we can start to make the footprint of ARISS on the station a little bit smaller and more contained, which is always a good thing because space up there is a big premium. But we need people's help. The space qualification, the design, the building of all of these units, including the engineering model which has gone through all the testing, has been done by volunteers. The space certification side of it has been carried out for the very first time with NASA by volunteers. So no organisation has been brought in to run it. So the ARISS people, the ARISS engineers in the US, have been the ones that have been working the safety certification with NASA. And it's actually turned into a really good process, to the extent that NASA potentially want to use it elsewhere as well. The flight model has been built and is undergoing certification and safety checking and everything, and the last tweaks. We have secured our upmassing capability, and one of our partners, Keynes in the US, who helps sponsor us, has offered to provide us with the upmass capability. But the thing that we need to do, as I said, is that we need to raise the funds to actually buy the hardware parts itself. And there is a fundraiser activity going on. If you go onto the the ARISS website, the ariss.org website, you can very clearly see the fundraiser activity. Why do we need to raise funds? Well, the hardware bits we have to buy ourselves and we have to put together, and that costs money. What I'm really pleased to say today is that AMSAT-UK at a recent committee meeting has pledged £5,000 towards that funding programme, and we are seeking matched funding from organisations in the UK and elsewhere where we can help to try and boost this. We need 10 of these units, of the units I just showed you, purely to cover what's needed in the Columbus module, the service module, the on-orbit spares, the flight spares, the training modules, and then the development modules, and the ground-based system as well. So there's a lot of money to raise for this, and I would urge you, if you can, or with your work, if you're working, to seek ways of seeing how the funding, or how we can get some more donations towards the ARISS programme. So HamTV, really successfully used in the Tin Peak mission. We had 7 out of the 10 contacts that were using HamTV. brought live video from the space station directly into a school, which was a world first for everyone on the amateur side. We brought it into the school, and the reaction of it was absolutely phenomenal. The number of times that we were sitting there, we could see Tim giving everybody a wave, and then only to see this sea of young children sort of waving back at him was absolutely brilliant. The impact was phenomenal, and it was really, really good fun. But it's broken. It stopped transmitting somewhere earlier in this year. We've done a number of investigations around and about to actually try and see what's the problem. We don't know what the problem is, and as a result, we're going to downmass the unit. Now, it takes a bit of time to actually plan all of this. One of the problems is that the original agreement with HamTV was that if there was a fault on it, it would be put into a progress vehicle. And if you know what the progress vehicles are, they end up with a nice big fiery sort of display on the way back. So we've had to work to get the unit transferred across so that we can actually downmass it. We've then got to get it back to the manufacturer, Kaiser Italia. We've got to then get it fixed. We have to be careful on the fixes that we apply to it, because we don't want to invalidate the safety certification or the flight certification for it. And then we want to get it back up there again, because it was so good, and the result of it was, and the impact of it was really good. Currently, we're looking for no earlier than fourth quarter 2019 to be able to get it back up there. It could delay. We've all seen the consequences of space flight in the last few days as well. Who knows what that's going to cause to it, but we're hopeful that we can work with it in order to get it done. But we're not sitting on our laurels waiting for that to happen. We're actually pushing ahead. So whilst we're designing and building the interoperable radio system, we're also looking at HamTV 2. What can we do with HamTV 2? What enhancements can we make that actually take what we've done and actually bring it to the next level as well, which is something we see as really important because of the level of engagement that caused with the school students that we were involved in. So some ideas that we've been playing around with: higher resolution, which would be great, a modular approach. So instead of having a brick, colloquially speaking, of one box doing absolutely everything, and then if one little bit of it fails, the whole thing fails, we're looking at a modular design so that we can eventually have PA encoders and everything as literally slide-in modules, so that if something fails, we can pull it out and put a new one in. Again, the main goal that we're looking for is trying to get things done on orbit with as little crew involvement as possible. We're trying to be as autonomous as possible. But it's going to be a significant project. And again, that will require funding in some way, shape, form or another. So my main message on this point is that we've got a lot of positive things going on with ARISS, but we do end up at the end of the day spending real money to actually get the hardware. And it's not just the cost of the hardware, it's the cost of the safety certification, the flight certification, the backup units, the spares, the training units, and it's all those things that we still have to work for. But why have the station there, or why have that capability there in the first place? Well, the whole raison d'etre of ARISS is STEM outreach. We want to engage students. You've heard from Eleanor and listened to what involved for her and for the young girls and boys at Warwick and Warwick Prep to be involved in it. But what about older students? What can be done to interest them? And this is where a project called Markinista has popped along, and it's actually a really interesting one. Essentially, it's a Lime SDR, which is in a receive-only mode. Don't go there in terms of transmitting on the station, because that then introduces a whole host of other problems that you have to deal with. But essentially, Markinista connects to the ARISS antennas, not just the L and S band patches that are radar facing on Columbus, but also the UV antenna as well, and is carrying out a set of experiments. And these experiments are being done and controlled by TU, the Technical University in Berlin. So we've now got a university-led project being run itself. And it's part of the Alexander Gerst mission, since Alex is up there at the moment, and has finally been commissioned and has been returning data back to TU Berlin since August. So an experiment that's looking really good. Like I said, it's the Lime SDR. It's controlled by one of the AstroPis, so one of the computers that Tim Peake used when he was up there, and which ESA Education have subsequently taken on and are advocating and using across Europe and elsewhere. We've coupled it into the ARISS antennas. Again, one of the things that we wanted to do was avoid having to have switches, because a switch needs a crew member to actually go and switch it on and switch it off. So one of the things we've got up there this time, for the first time in our equipment certainly, is a directional coupler. So we've got the ability for the Markinista project to be running all the time, and the crew don't have to do anything when they come to have to do an ARISS contact or a schools contact. It's all automatic for them, and that's one of our key goals. But it's taught us a couple of things that are interesting in terms of where we go in the future. Like I said, it's using the AstroPi, which is, if you know the Raspberry Pi systems, it's a Model B, so it's actually a single core processor. Still quite a powerful little computer, still capable of running the Lime SDR without a problem, and we're looking forward to seeing the results come out of that. So what were the primary goals? Well, one of the things Markinista wants to do is actually look at the satellite spectrum around the world, both at different times of the day and potentially different times of the year, and try and find out just how heavily used it is, or whether it's polluted, or whether there are some signals in particular areas that are causing us problems around the world, and wanting to look at UHF, VHF, S-band and L-band. They're going to use a number of algorithms to actually try and pick out a load of information from it. We haven't seen anything. In fact, I'm off to Washington next week, where we're getting a presentation on it, and hopefully start to see what information it's actually delivering for us from space. But this is a project that's running pretty much 24 hours a day, 7 days a week, and then with the assistance of Biosec. I think it's Biosec, one of the units in ESA in Europe. They periodically log into the Pi for us. They extract the data, they pull it down, and they pass it on to the TU Berlin. That's the primary goal of it, but it would be a waste to actually just let it do that and that alone. So there's a whole host of other things thrown in. So they've actually put a secondary project objective onto it, which is looking at a much bigger part of the amateur spectrum and trying to see what's the impact in space of the amateur spectrum. Plus also that's really important for us is the ability to then assess the radiation pattern properly on the antenna. If you know from some of the stuff that we did in Columbus, there are some restrictions in terms of the types of contacts we can do. Depending upon the orientation of the station to the ground station and its maximum elevation, there are some restrictions that we know cause problems, but we don't know in great detail. So Markinista offers us the ability to have some antenna patterns actually calculated properly for us. What happens afterwards? Well, TU Berlin / ESA have said they will turn the Markinista project over to ARISS. The Lime SDR, a very little tiny little box, will hopefully be handed over to us, and it's an opportunity for us to now say, well, what flight experience can we gain with an SDR in space? What can we do with it? One possibility is that we could leave it connected to one of the L-band antennas. Could we turn the Lime SDR into a DVB-S receiver? Can we send DVB-S signals L-band up? and let the crew see the schools taking part in the contacts themselves? We don't know. But the whole point is it's all about experimentation, ideas, and developing the concepts. What's important here is that actually, if we can do this, it gives us a good basis for when we go on to what we call the Deep Space Gateway, or the Lunar Gateway, which is hopefully the next orbital outpost, where we want to be able to have equipment there as well. And then when crew members are actually visiting the outpost, that we can conduct contacts with schools in deep space. Just another development, but it's something that we want to look at. But we're open for ideas. So if you actually have thoughts or suggestions, absolutely no problem with you coming forward with them, dropping us an email or whatever, to try and find out a little bit more of what's going on. Now, I've just realised I've left a slide out, but I had one last little bit, which was STEM outreach that I wanted to do. We've talked a lot about it and what do we do. Eleanor will know very well that the approach that I take to it is that I try to encourage the schools to actually be inventive and be thinking about what they're doing to engage their students. But we've also thrown in a few odd complications along the line. And one of the ones that I did with Eleanor's school for the first time was set them a little puzzle to see if they could calculate the surface area of the Earth that is visible from the ISS. Assume the Earth is a perfect sphere, makes it a little bit easier, but how much of the Earth's surface can the ISS see using nothing more than basic trigonometry? It can be done. If you want to have a go, try it. I'm downstairs. I've got the printout that shows all the calculations. It's basically algebra, a little bit of Pythagoras, and a little bit of sphere geometry as well. Very, very easy, but I don't know if you actually undertook it. You did? So Eleanor knows the answer as well. So you can have a go. It surprised me when I did it, but then when you sit back and think about it, it's sort of there. And that's putting a little bit of the mathematics into the STEM that we do. So have a go at it. A couple of preconditions. You assume the space station is 400 kilometers above the Earth. Assume the Earth is, what is it, something like about 6,700 kilometers in radius. That's all you need to know. So have a go. If you can do it, we can talk about it and make an announcement to see if anybody gets the answer right. But it's quite a good challenge, and it's a fun thing to get students thinking about how they apply the skills they've learned from multiple different lessons and different subjects, and actually bring them all together to solve a real problem. So, like I said, this is the ARISS update. We've had a really busy year. We've got a lot coming up. Joe will be talking a little bit more about the future as well. It looks exciting. We've got 2 more contacts coming up in the UK within the next year, which will hopefully keep the focus on what we're doing and how we're doing it. But we're always interested in more schools. So if you are looking, or if you are linked to schools that have an interest in doing this, following what Eleanor did, following what the schools in Principia did, please get in touch and I can help you work the application process. It's still very difficult to get scheduled. Like I said, we've seen the consequences of the last couple of days as well. But hopefully that will settle down and we'll just carry on as normal. So last thing, the normal, the websites, the ARISS.org is the international website. ARISS-EU.org is the website specifically for the Europe region of ESA itself. And ARISS Status is the Twitter feed that is pretty good in keeping up with what's going on. Thank you very much.
Thank you very much, Ciaran. Eleanor, thank you very much for your talk. It was very informative and reassuring that youth has got a proper interest in the future of space. Do we have any questions on either of those talks, please, from the audience? Don't be shy. Hang on. If I could bring the microphone round 1 moment, please.
Is it planned to put the recorded lectures on the RSGB website?
I believe so, yes.
Okay. No, it
Oh, no?
isn't.
Thank you for that.
Oh, okay.
They will, in this stream, all the lectures and presentations will be available on YouTube very soon after. On the AMSAT channel.
Thank you. Do we have any other questions from the audience? Do we have any from the internet? Do we have anyone watching on the internet? We have one.
A question from Ian G3 ZHI. How many new hams has this brought into the hobby, and what do you think the cost per ham was there?
That's really interesting. I can't give you the number just yet because it's not for me to publish it just yet, but there is going to be a final report on the Principia mission, and you will be able to see exactly what the cost of setting up and running the Principia mission and the number of students we reached directly, so not including social media or anything else. These are actual physical students that took part in these activities, and hopefully it will surprise you. It surprised the living daylights out of me when I saw it for the first time. So I'm sorry I can't answer that question just yet, but it will be answered soon. In terms of the number of new amateurs brought along, I run a philosophy of trying to get the school interested in amateur radio as well, because we're doing satellite communications. That generally means that local clubs run licensing sessions itself, so it's not something I'm directly involved in. We did had quite a significant hit with Principia, and we had quite a number at every school taking part in it. Some schools have got a enduring legacy and are continuing to run amateur radio clubs and STEM activities associated with satellites. Those schools are particularly successful. I know there was 3 girls took the exam just before the contact, and there are 3 others who are due to sit theirs fairly shortly as well in Warwick. We've got a similar number of people doing things in Kenilworth. The Rowan School is for children that are 2 to 11, so quite how many of those I can get interested in is another matter. But the philosophy that I'm trying to engender is I make the hobby available as an example of what technology can do, and how amateur radio actually brings a lifelong learning commitment to things. You're always learning something from amateur radio, and trying to instill that in the students as an ethos. So I'm sorry I can't give you the absolute exact numbers, but there is a sort of a background, and we have had quite a number of students take place and take their exams during the Principia work.
Okay, thank you. Oh, another one from the audience.
It's not a question, but my name is Mervyn Foss. I'm G4 Cayley. I'm a STEM ambassador. I'm also a volunteer at the NRC. Mm-hmm. And when we get people coming in, they're so interested, the children are so interested in what we're doing with the Fun Cube, that we try and get the interest in them then. And mm-hmm. the few of us here who are volunteers at the NRC. So a bit more information about this would help. If you've got some leaflets we can put in there. I know we can get them ourselves, but something in there that could help us.
Okay, if we can just make sure we catch up over the weekend,
certainly, yes,
that would be good.
you.
Yeah.
Thank you. Any more from the audience? You're all very quiet. Internet? Mm-hmm. Nothing. Well, thank you very much, Ciaran. Okay. Eleanor, especially for your future. We take a coffee break now. We're back in half an hour at 11:15. and Neil's giving a talk on parabolic flight.